Solutions, Part 2. Let's consider our solubility curves. So take out your reference tables and turn to Table G. Your solubility curves should look something like this. Solubility is defined as the amount of solute that can dissolve in a specific amount of solvent at a particular temperature. Notice that we are comparing temperature on the x-axis with grams of solute in 100 grams of water on the y-axis. In other words, we're looking for the relationship between temperature and solubility. What happens to the solubility of a substance when we change the temperature of the solution? When you look at these curves, you notice that a lot of them are going up. I'm highlighting 3 of those curves in blue. Notice that as temperature increases, the solubility increases. Now these are all solids. That's a general relationship. That as the temperature increases, the solubility of a solid increases. Now, you see the 3 curves that are going down. I've highlighted those in red. Those 3 represent the solubility curves of hydrogen chloride, ammonia, and sulfur dioxide. What's interesting to note is that all 3 of these substances are gases. We can generalize that as the temperature increases, the solubility decreases for a gas. Well, let's now consider how we can use our solubility curves to determine the solubility of a substance. In our first example, we're trying to find out the solubility of hydrogen chloride at 30 degrees. So find 30 degrees on the x-axis and bring it up to the hydrogen chloride line. Extend it over 2 grams of solute in 100 grams of water, and we see that the solubility of hydrogen chloride at 30 degrees is approximately 67 grams in 100 grams of water. What about the solubility of NaNO3, sodium nitrate, at 50 degrees? Go along the x-axis to 50 degrees, extend it up to the NaNO3 line, bring it over to the y-axis, where it gives us the solubility is about 116 grams of sodium nitrate in 100 grams of water. Now, what about this problem? How many grams of hydrogen chloride can dissolve in 50 grams of water at 30 degrees? Notice that I highlighted the grams of solute per 100 grams of water. My problem is asking how many grams can dissolve in 50 grams of water. Do you see the difference? In other words, if I have half the amount of solvent, I should only be able to dissolve half the amount of solute. So, 33.5 grams of HCl. Be careful. Read the problem carefully so you can see if I'm asking what's the solubility in 100 grams of water or some other amount of water. Now you can solve this problem using unit analysis. The given would be 50 grams of water times the solubility as a conversion factor. Now there are 3 types of solutions depending on how much solute is dissolved in the solvent compared to its solubility. In other words, an unsaturated solution has less than the maximum amount of solute dissolved. A saturated solution has the maximum amount of solute dissolved. And a supersaturated solution has more than the maximum amount of solute dissolved. Let's consider 3 examples and try to identify the type of solution. Example 1. I have 30 grams of salt dissolved in 100 grams of water at 90 degrees. The solubility of salt at 90 degrees is 40 grams of salt in 100 grams of water. I'm going to put a red dot where my specific example is. 30 grams dissolved in 100 grams of water. What you want to ask yourself is, well, where is 30 grams of salt compared with the solubility curve? You can clearly see that it's below the line. It's below the curve. Any point below a solubility curve represents an unsaturated solution. Well, how much more salt could be dissolved in this solution? Well, if the solubility is 40 grams and I've only dissolved 30 grams, it makes sense that I can dissolve 10 more grams of salt in this solution. In unsaturated solutions, the solvent contains less than the maximum amount of solute dissolved. Remember, the solute has to be dissolved. Let's consider this example. 40 grams of salt dissolved in 100 grams of water at 90 degrees. The solubility of salt at 90 degrees is 40 grams. Now, I'm going to put the red dot where this specific example is, 40 grams. If you notice, where is the 40 grams of salt compared with the solubility curve? Well, of course, it's right on the line. This represents a saturated solution. No more can be dissolved in this solution. I have the maximum amount dissolved. In a saturated solution, the solvent contains the maximum amount of solute. Now let's look at example 3. I have 50 grams of salt dissolved in 100 grams of water at 90 degrees. Remember, the solubility of salt at 90 degrees is 40 grams of salt in 100 grams of water. Well, let's put our red dot representing this specific solution. Do you see that the red dot is above the curve? Any point above a solubility curve represents a supersaturated solution. Well, how much more salt is dissolved in this solution than should be? Well, I've dissolved 50 grams of salt, and only 40 grams of salt is really soluble at this point. That means I've dissolved 10 more grams. In supersaturated solutions, the solvent contains more than the maximum amount of solute dissolved. A supersaturated solution is very unstable, and the amount in excess can precipitate or crystallize out. In other words, those extra 10 grams of salt that have been dissolved, they will fall out of solution if I disturb it in any way, like stirring or adding a crystal, doing anything to it. Those extra 10 grams will fall right to the bottom of the beaker. Well, let's consider the solubility of salt at 20 degrees now. Do you see that the solubility is about 36 grams of salt dissolved in 100 grams of water? An unsaturated solution would contain less than 36 grams of salt dissolved. A saturated solution would contain 36 grams of salt dissolved. And a supersaturated solution would contain more than 36 grams of salt dissolved in the water. Let's look at this example. The solubility of salt is 36 grams of salt in 100 grams of water for these conditions. Now, if I add 30 grams of salt to the 100 milliliters of water, remember the density of water is 1, so 100 milliliters is in effect 100 grams of water. Doesn't it make sense that all 30 grams will dissolve? This is an unsaturated solution. It contains less than the maximum amount of solute dissolved. Can you tell me how many more grams can dissolve in this system? You're correct if you say 6 more grams can dissolve. In this example, I'm going to add 40 grams of salt to the water. Remember, the solubility of salt is 36 grams in 100 grams of water. How much of those 40 grams then can dissolve in the water? Since the solubility is only 36 grams in 100 grams of water, only 36 grams of that solute is going to dissolve in that water. That means 4 grams of salt will remain undissolved. Those 4 grams of salt will sit at the bottom of the beaker. It doesn't matter how much I add, it matters how much gets dissolved. The solubility is 36 grams of salt in 100 grams of water at this temperature. Now, a saturated solution is in equilibrium. It's really difficult to determine if a solution is saturated or not, and usually a saturated solution has a little bit of extra solid at the bottom. That tells you that the maximum has already been dissolved. Well, that little extra amount of solid at the bottom of the beaker, it's not just sitting there, it's engaged in dynamic equilibrium, which means that the solid at the bottom is dissolving, while at the same time, the dissolved solute is recrystallizing. The rate of dissolving equals the rate of recrystallizing. Notice the equation at the bottom. Salt solid becoming salt aqueous, and I have a double arrow there indicating equilibrium. Now, in a supersaturated solution, I have more than the maximum amount of solute dissolved. For example, if I've dissolved 45 grams of salt in 100 grams of water at 20 degrees, this has more than the maximum amount of solute dissolved. This is extremely unstable, and if I disturb the solution, all of the excess will recrystallize. A supersaturated solution is made by preparing a saturated solution at a higher temperature. Remember, in general, as temperature increases, solubility increases. That means more solute can dissolve in a given amount of water at 90 degrees than at 20 degrees. So if I prepare a saturated solution at 90 degrees and then cool it down, and I'm very, very careful, I can wind up with a supersaturated solution. Remember, the supersaturated solution contains more than the maximum amount of solute dissolved. Let's identify the following solutions. I have 115 grams of sodium nitrate dissolved in 100 grams of water at 40 degrees. Do you notice that 115 grams of sodium nitrate is the solubility? That means I have a saturated solution. What about 65 grams of sodium nitrate dissolved in 100 grams of water at 40 degrees? At 40 degrees, I can dissolve 115 grams, but I've only dissolved 65 grams. This is an unsaturated solution. But what if I've dissolved 135 grams of sodium nitrate in 100 grams of water? 135 grams is about 20 more grams than should be dissolved. It makes sense that this is a supersaturated solution.